In the previous video, we identified all the important angles on the unit circle in both radians and degrees. And what we're going to do in the next couple of videos is slowly derive all the coordinates at these angles. And what we're going to start with in this video is our angles of 0 and 90 degrees. So starting with 0 degrees on our unit circle, that's going to be the positive x-axis by our angle convention. And the coordinate is going to be here. And we should intuitively know that the coordinates here are going to be 1, 0, because we go across the x-axis 1 being the radius of the unit circle, and we don't go up and down, so our y component will be 0. So at an angle of 0 degrees, our coordinates will be 1, 0. And now let's interpret this in terms of sine, cosine, and tangent. So what will cos of 0 degrees be? Well, from our understanding of the unit circle, this will be our x component of our coordinate, and so cos of 0 will be 1. And we can do a similar thing for sine of 0 degrees, and this is going to be our y component, which is 0. And finally, we can do tan of 0 degrees, which is equal to sine divided by cosine, and our sine of 0 is 0, divided by cos of 0 is 1, and so tan of 0 is going to be 0. And let's also interpret these coordinates in terms of radians, and so this angle is going to be 0 radians, and so cos of 0 radians is going to be 1, being our x component, sine of 0 radians will be 0, and tan of 0 radians will also be 0 from what we've shown above. Now let's consider our angle of 90 degrees. And 90 degrees is going to be on our positive y-axis. And this is going to give our coordinates here, which we should intuitively know is going to be 0, 1. As we go left and right 0 units, so our x component will be 0, and we go up 1 unit because our radius of the unit circle is 1. And let's interpret these coordinates in terms of sine and cosine and tangent. And so at 90 degrees, cos of 90 will equal our x component, which is 0, and sine of 90 is going to be our y component, 1, and tan of 90 degrees will equal sine of 90 divided by cosine of 90, which is going to be 1 divided by 0. And notice that we're dividing by 0, and we should know that we cannot divide by 0 in maths, so we're going to leave our answer as undefined. So tan of 90 degrees is undefined. And we may as well show visually on the unit circle why tan of 90 is undefined. So remember, to interpret tan visually on the unit circle, we need our x equals 1 line, so let's draw that in. Remember that when we extend our angle line to intersect our x equals 1 line, the y component of this intersection point will be tan of our angle. But realize that when we extend our angle line at 90 degrees, this will be parallel to our x equals 1 line. And from our understanding of parallel lines, there will never be an intersection point, and therefore there can never be a tan value at 90 degrees. And that is why tan of 90 is undefined. Now let's interpret these coordinates in terms of radians, and 90 degrees is the same as pi on 2 radians. So cos of pi on 2 radians will be our x component, which is 0, and sine of pi on 2 will be 1, being our y component, and tan of pi on 2 radians will be undefined. So now we have successfully derived our coordinates at 0 and 90 degrees on the unit circle and interpreted the results in terms of sine, cosine, and tangent of these angles. And what we're going to do in the next video is derive the coordinates at 45 degrees and do a similar thing.